let's do some free response practice based on what we just learned about acid and base definitions. So in this first question, what I want you guys to do is, first of all, identify which of the molecules is going to be an acid and which of the molecules is going to be the base. Okay? Now I know that it can be a little bit confusing identifying both, but usually what we do is this. We look for the one that's most obviously the acid or most obviously the base, and then the other one must be the other thing. So in this case, which of these would you say is most likely the acid? Good job, you remembered your strong 6. So HCl has to be my acid because we know that it's a strong acid from Gen Chem. Okay? And that means that my water, even though it's not a very good base, this is going to have to act as my base. Does that make sense so far? Cool. So now what I want to do is I want to move the electrons to predict what the end product is going to look like. So what that means is that I have to remember my rule of how mechanisms move. Where do they go from? Where do they start from? Do they start from the acid or from the base? Well, in order to know that, we'd have to think about nucleophile and electrophile, right? So where do they start from, nucleophile or electrophile? Remember that they always start from the nucleophile, right? And the nucleophile is going to be the Lewis base. So that means that this is my nucleophile and this is my electrophile. Now all I have to do is figure out where this arrow is going to start from and where it's going to end up. Okay? So for my base, that's actually easy. We said that it's an electron pair a base is an electron pair donor, so I'm just going to start off from my electrons. Okay? Now I have to figure out where those electrons are going to go. And in order to figure that out, remember this has a negative charge, I have to draw the dipole of the other molecule and figure out where that negative charge is going to be most attracted to. So is there a dipole on HCl? Yeah. You didn't know dipoles were going to be this important, right? They are. So there's a huge dipole towards the chlorine. So there's a negative here and there's a positive here. So which one is my base going to attack? Is it going to attack the H or the chlorine? And it turns out that since this is negative, the electrons are negative, it's going to attack the positive. So I'm going to do this. Does that make sense? So my negatively charged electrons are going to attack that H. Now we have to use our principles of mechanisms that I already taught you. If I make that bond, is it happy? Can I just end there? Can I just draw my products now? No, I can't, because the H, remember that it only wants to have one bond. And right now, it already has one bond, and now I'm adding a second bond, right? Remember that every time you add an arrow, that's a new bond that you're forming. I'm just going to delete the dipole because I don't need it anymore. So what that means is if I make this bond, what do I have to do? I have to break a bond. And the bond I'm going to break is just the one to the Cl. So I'm going to take those 2 electrons, I'm going to give them to the Cl now. This is the break. Okay? Now we're happy. We're good. We can draw our products. So what that means is that now my product is going to look like this. I'm going to have my OHH, my water, but now it's only going to have one lone pair because of the fact that it gave one away. And now it's going to have a new bond. That new bond comes from the arrow that was making the bond. And then it's going to have an H on it. That H came from right here. Does that make sense? Cool. And then what's going to be on the other side? What's going to be on the other side is the Cl that used to have how many electrons before? It used to have 1, 2, 3, 4, 5, 6. So I'm going to draw those. But then notice that it also gained 2 electrons from when that bond broke. So now it's going to have 2 more. Now all I have to do is figure out the formal charges. So is the O going to have a formal charge? Actually, yeah, it's going to have a positive because of the fact that it has 5 electrons and it wants 6. How about the Cl? It's going to have a negative. Isn't that interesting? So now you guys have just learned how to draw the products of your first reaction. So congrats. That's like a huge accomplishment, okay? Just being able to draw the mechanism and predict the products, that's a huge part of organic chemistry. So you're already like well on your way, okay? Now what we want to do is use the definitions of conjugates, and I want you to tell me which one's the conjugate acid and which one's the conjugate base. All right? So go ahead if you want, pause the video and tell me which one's the conjugates. Which ones are the conjugates? All right, guys, so the rule was really easy here. Remember that I said that the acid becomes the conjugate base. So that means that my HCl is going to become my conjugate base. Because the Cl was part of the acid at the beginning, okay? And what that means is that my base becomes the conjugate acid. Because that used to be my base. Now, let's say that you forgot that rule. Let's say that you forgot that base becomes conjugate acid and acid becomes conjugate base. You could still figure this out. How? Because you would just look at, okay, which one has the positive charge? The acid is always going to be the one that has a positive charge. Which one has the negative charge? The base is always going to be with the one with the negative charge. See how that works? So it actually makes sense what's going on, even if you didn't remember the rules. All right? So are you guys feeling good about that first one? Let's go on to the next one. So for this next one, I want you guys to pause the video and do this entirely on your own. So do the entire problem. Try to figure out, first of all, where the arrows start from. Try to figure out where they go. Try to figure out where the acidic hydrogen is, because this is acid base. Okay? And then try to figure out what the conjugates are. Basically draw the products. And also provide the mechanism as well. It's a lot of work, but I think you guys can do it. Okay? So go ahead and pause the video and just experiment with this. Use the example I gave you at the top to try to figure it out.